So I've been through Y2K disasters that didn't happen, SEC compliance nightmares, legal battles, all that good stuff that IT people get to do. And I want to share with you what I learned and um, how that influenced my awk-based replication script called Zelta. So about me, I've been building infrastructure for 25 years. I'm a sysadmin and fractional CTO for clients in New York City. I work mostly in financial services, healthcare, and other clients that have serious regulatory needs like law firms and others. My mission is to create a perfect backup, and I work in industries obviously where "oops" isn't in their vocabulary, and as I've been using ZFS since I guess about 2008 or 2009, I was immediately drawn to that as a tool, and and started building my own backup system to make that work. So um, let's see. Yeah, so my journey through compliance hell. So I got my start on as a sysadmin on Wall Street in 1998. So I worked for Jeffries and Company, which is uh, a major broker dealer and investment bank. And at that point, I learned that whoever controls the blocks controls the universe. Um, we had to make a plan to figure out how to get the Jersey City office completely moved over with skeleton crew to the disaster recovery sites, and we did that pretty much with DD. Basically back in the day, it was just streaming blocks, just like we kind of do now. And then in 2000 to 2002, I became a VP of IT on Wall Street, where we're dealing with SEC regulations and understood that your backup is a legal requirement. It's not just for the safety of the what you're backing up. And then as of 2019, I started building out my own hybrid cloud infrastructure. So and I've and that was mostly a cost saving idea, but at the same time, we also um, wanted to have total control over the data of my clients. So I've had to deal with all sorts of regulatory concerns, working with suppliers from Google, to Twitter, to CZI, to the New York City government, all with different regulatory complaints and concerns. HIPAA, FINRA, NYCRR 500 is the recent one, PCI, DSS, DFARS, the works. So we had to deal with making sure everybody's data and workflows matched all of this. And then looking to the future, uh, there's we realize that compliance isn't just security theater. Um, there's going to be a new army of Gen AI script kiddies that absolutely hate your IP blocks and never sleep. So we need to be really serious about this stuff. Um, so I've developed over the years a set of backup principles um, that I've been going for. One is that I think the backup tool should be essentially hierarchy agnostic. So it shouldn't care about the names of the data sets and instead should look into metadata. Um, I never want to destroy data because that's your audit trail. I want everything to work remotely and recursively, and I want to detect and use the best available features at all times. Um, additionally, I want to have some shortcuts that can help you out at 3 a.m. If some emergency occurs and you need to roll back. You need enough safety without, the pure power of ZFS. Um, oh, sure. All right. So another one of my principles is that I like Unix. Have been using it for a long time. I've been half Linux, FreeBSD as of late, and other Unix operating systems. And we're working with an incredibly rich ecosystem. Uh, SSH is magical. I'm still learning new features of what it can do. There's already great tools for snapshot scheduling and communication between servers. I don't want to. I intentionally don't want to reinvent any of those things. I mean, use the tools that are best for the job. The tool that I made, Zelta, is essentially handling that particular problem, and it doesn't do snapshots and pruning. It doesn't do these other things because those things are already perfected in Unix in general. Um, so over the years, over the last 6 years or so, I've been managing ZFS more and more every day. And there are essentially three different approaches that I have to use all the time. And different tools seem to focus on those specific approaches. So, for example, raw ZFS power. I think that in small setups, and I'm speaking as a production user rather than a developer, I think that a lot of people will use those ZFS tools for maximum control or building their own scripts, as I have. Of course, that does give you just enough rope to hang yourself with, and there is, some risk, but it's obviously necessary. But if you want to do some serious business kind of recoveries, you do need to get inside the ZFS commands and do some spelunking. Um, the next type of ZFS management is centralized with policies. So a centralized system like a GUI-based backup tool and so on that gives you ease of use and standardized environments. And I think the risk there is you can end up with Scotties. You can end up with situations where everything's handled by a single pane of glass, which everybody supposedly wants, but it is a little more difficult to separate roles, which is critical for the regulations that I have to deal with. And then finally, there's a security first method, a security team approach to these things. So Zelta's define is built to work with ZFS allow. It is assuming that nobody has access to any one specific choke point in the backup system. Um, so there is never uh, a standoff situation where, your backup server can damage your production server or something like that, which is actually built into the DNA of some of these other centralized management tools. So I'd like to go over those different approaches and how I've written Zelta to help me do those more efficiently. And of course, I just want to mention that, you know, I'm not particularly selling Zelta here. I'm just saying that these approaches are critical for what we're doing. So the first is, perfect precision in ZFS raw power. So in my previous Zelta um, presentation last year, I went more into the technical details, but I'm going to talk more about philosophy this time. So, basically we want to use raw ZFS power when we're handling simple migrations, recovery. I mean, you pretty much want to, want to want to at least have access to the ZFS commands when dealing with a recovery situation and custom scripting. Uh, but as I say here, with great power comes great potential for career limiting events. So I've definitely seen situations where someone's backup, um, someone's backup workflow flow caused potential risks of spoliation of evidence in legal situations. And I've seen people get sanctioned for somehow producing a backup that was just too old for a case that they were involved in. Obviously, I can't go into many details there, but that's not a one-off event. Um, and also, we want the raw power of ZFS when we're dealing with extremely locked down environments. Um, so I've developed Zelta to just help me with those situations. For example, one of my clients, I get a VDI with no internet access. I can paste in a couple of scripts. Thankfully, Zelta's portable enough to help me with that. So all commands are already recursive by default. I have great portability. Um, so to talk about portability, I've explicitly written at least the version for now completely in Kernighan awk and SH, and my requirement is SSH, which, as far as I know, um, works on most of your computers. Um, so I'm going for extra super portable. I want to be able to talk to a TrueNAS 9 box and make it replicate to a modern ZFS box of any kind. For example, I want NFS to be able to I want NetBSD to be able to replicate out of something which is lagging behind in some ZFS features. So I want absolute portability. Most of my QA is done in Linux, but my fleet for my private cloud is built completely in FreeBSD. So it's well tested with millions of snapshots in each one. Now, in terms of my opinionation, I'm making some choices that the ZFS commands didn't make at all, but I think are useful for daily recovery work and daily backup work. So it is, Zelta backup. So I've actually decided to make my scripts set read-only on their first replication. So the backup is a backup. It simply it resets mount points. It doesn't do anything that could surprise you. In my one of my previous demos, I showed that by doing the most natural thing in the world, which is taking your backup and doing a ZFS replication with the minimum number of commands required from a root mounted FreeBSD box or Linux box for that matter, will confuse the user in that it will automatically mount on top of your mounts, and you won't know which copy has your data on it. So that's a bit of a risk, and that's a fantastic feature, but not a backup feature. So yes, so Zelta backup really means backup. Here's some examples of my commands. So Zelta backup will snap, set read only, and so on. And Zelta match will describe if two data sets are in sync. This is hugely helpful. When I've gone to when I've gone to organizations and they have an old backup, they've set things up without me. I want to know what's going on. And Zelta match is a tool that I use to probe and see if the data sets see if the data sets and all of their histories are similar. So that's something that I use frequently. And then for recovery, of course, there should be some shortcuts. We assume that ZFS is going to mount something when you replicate it, but maybe that's not a good idea if you're planning to replicate onto it again, because it'll instantly cause the backup to diverge. The typical solution to that is ZFS receive -f and clobber potentially your history. Um, we suggest you recursively clone those things. So anytime that you're looking at a backup, you want to check to make sure it's good. It takes absolutely no effort to simply clone those snapshots and make sure that they're good. So we added some training wheels for that. And then finally, one of my favorite features of ZFS or of Zelta and of ZFS is that we can simplify the process of rotating backup sets when some divergence has happened from the source. So I've created entire workflows based on my rotate function, where the target is always flipped. If the source changes, if the source diverges based on a clone or a rollback, the backup is kept intact, and it's sort of like sort of like a system log rotate. It'll rotate the target, and you keep the entire tree of data. So that is all of your that's that's your evidence of something that happened, some reason that you've rolled back. You now for sure have, including uh, sort of the the clone point. You get everything on both boxes during a normal backup process. So this is an example of Zelta match, and it provides a plain language out output. So basically, language that even an auditor can understand. And a Zelta backup uh, example. So since we're looking at metadata, we'll only replicate if there's a change to the source data. So an interesting thing about this is you can take Zelta and point it at two twin servers. So your primary and your failover, your uh, primary and secondary, and simply point them at each other. So as long as you set read only after your last replication, it'll you can basically set two servers, have them point at each other, and they'll in whichever one you decide to set read write in boot will automatically get replicated over to the other one. That's just a matter of putting both commands that respect each other and are opposite of each other in cron, and that's all it takes. You can also set your backup servers to pull from both of those places. And if you remember to set your read-only flag, they will not diverge, and you can back up directly from both of your both twin servers. So if you have a primary and secondary, you get everything everywhere. And then a little more information about, I think I already went over the rotate command, but it'll check for various types of diversions, like a source rename and clone or a rollback. It preserves the target changes, and it's an immutable replica history that satisfies any retention policy. So yeah, I also have used this for QA schedule. So some if an application that's doing QA, um, we only want to store the deltas between the application as it's tested. Maybe you test, maybe you take a version in the morning, compile it, and and run it. So we only have the deltas, but we can go back and get a very efficient history of everything that happened during the testing process from any day that the change happened. I've also used it for our databases. So a database gets some interesting thing happens to a database, but it needs, for whatever reason, to roll back to a particular point every day. And we've set up rotations, so we can get a copy of the QA version of the database from any day at any point, and that can be incredibly useful. I think the next talk is actually going to go into some detail about some of that kind of idea. And it works recursively, like everything does. Works recursively over file system boundaries, as long as the two replicas are within sync. So it will recursively do that rotate command. Um, this is a shocking amount of ZFS command code to look through. A shocking amount of lists, figuring out which transaction group is which and from where, and so on. uh, so this tool makes it pretty easy for me to keep my evidence when I want it. So the other way people use ZFS is a centralized system. So I would say probably most people use it that way. They're going to use a single, a single tool, a single uh, one piece of YAML that takes care of everything, which of course has its big benefits here. Um, so this was a bit of an evolution for me because I was like, oh well, I do want to centralize everything, and also I want some other features. Like for example, if my backup server is pulling from multiple sites, I can get quite a nice boost if I'm running from each site, and that's a separate thread. So so three ZFS send receives if I'm pulling from three different sites. That can give us a big performance boost and get our backups done before morning comes. Um, so so I definitely wanted to have some of these great strengths from the operator approach. We want so fully centralized and standardized environments. So the changes that I did were, I think that a lot of times there's just too much, like, and this is true for snapshot cleanup tools like ZFS Snap as well, and some of these centralized replication tools. They really care about the name of the snapshots, which is fantastic. Everybody wants to use everybody wants to sell your tool and make sure that they've only ever used that tool in that particular way. But that's not the reality of things. People have been using OpenZFS for a long time now, and there isn't always going to be an agreement between snapshot naming schemes and so on. So I want to focus on what matters, which is the transaction group and the metadata, and be agnostic about snapshot names. And I also want to make the assumption, so this is another opinionated choice, that I assume no root for anything. So I'm making those decisions, which are a little bit different than what most centralized command centers would typically use. All right, so here's an example configuration file. So like CFS, and I have more complicated examples elsewhere, but you know, essentially auto retry and run an X number of threads to pull from X number of sites at the same time. So we have, obviously there's the host and the data set level. We also added a site level. So we run a thread for each site, with the assumption being that there could be some benefit from your backup server to pull from multiple sites at the same time. And of course, just like ZFS, all of the options are hierarchical. And then we can output into JSON. So, you can feed that into your network monitor or your, um, or other monitoring tools. This is really useful for me because, we can watch and, check these now and then or get alerts, because let's say a ZFS list is taking too long, that's a signal that it's time to prune. Or, we want to watch and see what's going on with this client that's eating up more and more data over time. And then finally, as I started to build out a private cloud, something occurred to me, which is part of my career path, which is, for regulatory reasons, there are absolutely necessary reasons to separate all of the jobs that are involved in backup and retention. So we're focusing on five distinct roles, and this is more about implementation. This isn't something that's built into Zelta entirely. It's just the philosophical approach to this is assuming that there are different ways to handle these things. And the best way to and the way to handle backups while protecting privacy and security of your users is to separate the different roles. So we have production, failover, snapshot, backup, and retention admins as separate roles, which fit perfectly well into the ZFS allow command. So my feeling is, because ZFS allow is so good, that should probably be in the DNA of backup tools that are really targeting people that have extreme regulatory needs. So if you're dealing with SEC or FINRA, like, you have to have separation of privileges. It's not an option. And sudo is not a universal command prefix.
So based on that, are there additional like granularities or anything in ZFS allow you'd like to see? Like recently we upstreamed the ability to say this user is allowed to send a data set, but only in raw form. So if you were using ZFS encryption, the backup software can take an encrypted backup of it, but it can't take an unencrypted backup.
Yeah, that's great, Alan. I mean, that's
Like, are there more like that? I've seen.
yeah. I mean, that's one in particular that keeps me up at night.
There's the allow destroy,
Hmm.
but there's no
Allow snapshot destroy. Yes.
recursively. Like you can limit destroy to be only children of this data set, which would be the snapshots, but it also includes children, which isn't necessarily what you want.
Right.
Are there even more of those that would be interesting given all the work you've been doing in this area?
That's a good question. I have to think about that some more. I know that I would say yes. I think
Clone wish list.
yeah, there's definitely a wish list I'll provide. I think there's some interesting thing with clone boundaries. So it seems to me that when you replicate a clone, it has to be aware of the clone boundary. So a clone is not it references a snapshot, but it isn't a snapshot. And I think that there could be reasons why I would want to limit which clones somebody can replicate. And also on the flip side of that, it might be important to have some ZFS allow magic to reference a clone. So even if it's not in the same sort of volume tree. So in other words, I give ZFS allow to a particular data set. What if the clone isn't its parent clone isn't in that place? That could be a problem for a backup operator. But I mean, maybe that isn't a problem, and I just don't know it's not a problem. Um, I'll have to experiment with that. But that's great. I will absolutely come up with a wish list for this. Um, but the
So I did have one question about the different privileges. I'm so glad your least privilege definition is okay.
yeah,
It's going to be on the next slide. Great. I'll let you finish that.
yeah. So right, privilege separation is gospel. So here's some basic ideas. Like a production admin, I wanted to snapshot, rename, and clone. The failover admin, depending on how we define that, we might want it to be able to receive as well. I mean, I would love to be able to say you're not allowed to snapshot if data hasn't changed, but I think that's more for tooling than it is for ZFS itself. A snapshot admin, I think that the snapshot admin actually should be a different job than the actual replicator. I think the replicator should have snapshot capabilities for sure, but I do think that RTO RPO point should be set by a snapshot administrator. That should be a thought and a process and a cron job that's separate from the replication job. I don't think that those things should be intermingled necessarily. Sorry?
It's a business function.
Right. Yeah, there's two concerns. There's the replicas and then there's the snapshot and pruning. Are we, like a different user, a different team member might be making those decisions. Um, and then the backup admin should have very little delete access, in my opinion. But then once in a while, those ZFS list commands are starting to get a little hairy, starting to get a little long, and there has to be a retention admin that does that. In reality, I switched to root for certain things like this. But if the team was large enough, I think that these should be separate users and separate roles. There's really no reason to go into root with ZFS.
Do you have use cases where you'd want to separate out the destroy a bit more? I'm thinking like we don't want to necessarily take away the replication tool or the pruning tool's ability to delete snapshots in general. But say there was an incident or something and you've made a snapshot that is maybe litigation held or some other thing where now no level of automation should be able to delete this snapshot. Like you should have to do 2FA authentication to delete this snapshot.
Right. Yeah, I think that's tricky because I think I mean, yes, the answer is yes for sure. I think that it could be tricky because ZFS is not remote aware. So it could like some of those decisions would have to do with the relationship between its replicas. For example, I would never want to be able to delete a snapshot until it's replicated and then possibly bookmarked. So
So have you looked at using ZFS hold
yeah.
so that every time you make a snapshot, it's held and you only release it once it's replicated?
Yeah, absolutely.
Uh,
Yeah.
would there be a use case for, removing a hold requiring, a human who's been authenticated beyond the normal just has root?
Yeah, for sure. I mean, I think that would. I think that there is this sort of problem with the way somebody can attest for their SOC 2 or whatever, and are people really separating things down to that level? I mean, it would be nice if ZFS is the first the first file system where you can say if you're not using us, you're probably lying about this because we actually have the capability to say that this is held. This is held in a absolutely true way. There's also the inverse of that, which I was just thinking of while you were asking the question, is that there's sometimes situations where a certain amount of data should be redacted, and I don't know if this the redact snapshot command is robust enough to handle specific edge cases. That is, go inside the snapshot and wipe out specific client data, for example.
And to being able to keep the audit trail.
Exactly.
That's the key of all.
Of course.
Right. I mean, I wrote redact, so if you have questions about how it works,
Oh, nice.
I can answer them.
Well, what can you like? Can I? So if there's a diff, and can I point at a snapshot and say that that diff doesn't exist, or something like that?
Yeah. So the way that redact will work for the use case that it sounds like you're talking about basically is that you would want to create a clone of the snapshot that you're trying to redact. And then in the clone, like delete the relevant stuff, like replace it with garbage, whatever you want to do. And then when you do a redact, it looks at the diff between the thing you're redacting and the clones that you specify. And then anything that's modified in the clones, in all of the clones, because it's like a union something,
Right.
it will redact specifically like those blocks from any sends that you do.
That's awesome.
Yeah, so it'll do that like at a per block level in each object.
That's great. I thought it was per snapshot level, and that's just a misunderstanding I had.
It operates a snapshot at a time, but it uses the clones to see which blocks it should redact within the snapshots.
It's amazing. Amazing. All right, so ZFS does more than I ever dreamed. All right, so on my quest for the perfect backup. So what else could we do? I mean, ZFS is already really close, closer than I thought, evidently. But there are some things that I would like to do eventually, which might not be part of this super portable script that I wrote. Maybe it's a separate project or an offshoot project or something. But I but from the portability perspective, I kind of think that there shouldn't need to be anything at all installed on the servers that have ZFS. So rather than, I typically run it on my backup server as a pull replication. So that is my primary servers tend to have the largest attack surface. My backup servers tend to have very little. They're not directly accessible, for example. And there's a pull backup. So that's reasonably paranoid, but maybe not paranoid enough. So I think that a nice backup tool could be like a bastion on any operating system. It doesn't really matter. It can be an OpenBSD bastion. Now, OpenBSD doesn't have ZFS support, but it could absolutely be a little appliance that wouldn't actually need anything but the ability to run awk for comparisons and run on a single machine and then orchestrate and initiate between two servers for that backup step. that means that the backup server itself does not need to have an SSH key at all to the production server. So your your retention manager, your retention job wouldn't actually need to have access to the production server at all. They could go through, delete and redact what needs to be done, and still not have access to anything. And then, of course, that orchestrator machine wouldn't have access to delete anything. And an even better feature would be if you could limit only raw replications, then they couldn't even see the data. That would be incredible. And then I've been thinking about an even slightly more paranoid backup where we could use where we can't necessarily trust the replication streams, or we can't trust ZFS itself. So if we want the perfect backup, then I think you could solve this with ZFS and ZFS. So you could use a user space ZFS implementation or VMs, which could then be snapshotted by the host operating system. And then you could eliminate a possibility of a total pull destruction event from a massive ZFS bug that got through, or some evil way to send replicas. I assume that the reason why AWS's implementation of OpenZFS does not allow direct replicas in, though maybe that's going to happen someday, is because of some concern for that type of event. So, yeah, I'm not. So I think that would be a huge boon to everybody to get a user space version of ZFS out there. And that would also improve the portability of the project, and I think solve some potential problems. So yeah, so I would definitely want to ask the audience what what their ideas of the perfect backup might be, and I think that's it for me.
Show of hands who actually use the Zelta.
A few quick things. Thank you, Daniel. A client of mine split the company into two after 40 years, and a NAS that is full of stuff from 40 years where the boss's car is in the same directory as the forklift and I spent a week in Zelta just making sure that as I move stuff and split the baby, just make sure that everything's in sync, and it just tells you. It's like up to date, not up to date, up to date. So thank you for that.
You're welcome.